Hello students, hope you all are doing well. So here in this video we are going to take a look at the reactions of S-block metals hydrides with water. It's first group, second group, those metals hydrides, their reactions with water, which we are going to consider here. Okay students, do you know what hydrides are? When those metal cations are having H- anions, we call them hydrides. Those hydrides, actually it's not regarding only S-block hydrides. We could here consider any ionic hydride under this. It's ionic hydrides. In general, ionic hydrides could react with water in a manner like water separates into H plus and OH minus. Then minus to minus, they do not combine it. They hate each other, right? So then plus to minus they get attracted. So they form H2 and it remains OH minus after given of H plus by water. That's the idea. That's the idea of this reaction. Then let's take a look at those example reactions. Having those first group, second group, those metals hydrides. Then students, I'm going to write first group metals hydrides. It's starting with lithium. It is lithium hydride, sodium hydride, potassium hydride, rubidium hydride, cesium hydride, and I could write francium as well, but it's a radioactive element, does not exist. It's not actually stable much. So let's skip that. Then I could write the other second group as well. Beryllium hydride, so magnesium hydride, calcium hydride, strontium hydride, barium hydride, then radium, also radioactive. So let's not write the radium hydride. So then students, it's their reaction. Here we are considering with water. Okay. They are going to react. We are going to check whether they react with water or not. So here with second group, hydrides. Okay, when you check for their reactions, all the first group elements hydrides are ionic. Then they all react with water, forming hydrogen gas and metal hydroxide. This separates into H plus water. This separates into H plus and OH minus. This separates into Li plus and H minus. This H minus combined with H plus from water. So they form H2. So it is one water molecule gives one H plus and one LiH gives one H minus. They form one H2. So it's Li remains and OH remains. LiOH is the other product. So it has not balanced. So similarly, I could write balanced chemical equation standing for others as well, because they are going to react similarly, the same product. So it's H2 and respective metals hydroxide. Then you would get lithium hydroxide, sodium, potassium, rubidium, cesium hydroxides with H2. So then it's regarding second group metals hydrides reaction with H2. Then you need to take a look at their ionic and covalent character. It's down the second group their ionic character will get increased. The first member, beryllium, is quite covalent. It takes a bit covalent character for the reason it's having the greatest electronegativity. Out of all the S-block elements, beryllium is having the greatest electronegativity. It's 1.5, isn't it? Okay, so therefore it's close to the electronegativity. It's not equal, but it's not very close, but it's slightly close to the electronegativity of hydrogen. Therefore, they are having quite covalent character in their bond. So therefore, it's quite covalent, the character it exhibits. So then its reaction here is quite weak. It's very slow, the reaction. That beryllium hydride exhibits with water. But others, they could react. Down the group, their reactivity increases, their hydrides reactivity with water. So anyway, they all do react. Though beryllium is very slow, its beryllium's hydride reaction is very slow, it also executes a reaction here. So then they separate this as Be2 plus and H minus. Its 2 of H minuses would be given. Then we need 2 of H pluses from both. To do that, we need 2 of H2Os. Then 2 of H pluses with 2 of H minuses there, it is 2 of H2s you get. Then it remains 2 of OH minuses, it's with Be2 plus. You could write it as BeOH twice. Okay, then similarly you could write equation standing for others as well. It is 2 of H2 all the times you are going to have. It's then their respective hydroxide you get here. So it's very easy. Once knowing the logic, you could easily apply on all of them. You do not need to memorize these things, these stuff. So then it's you could see that it's a logical subject. It's a logical subject, this chemistry. So therefore, you do not need to suffer this subject, memorizing these all the reactions. It's not lists of reaction. You don't ever tell others when they ask what kind of subject this is. So it is not by hearting lists of reaction. It's actually not. It's finding out logics. You could easily get the products. That's why it's that beautiful subject. So you just need to realize that and enjoy this. So hope you could understand these easy few things, few logics. Okay students, we are going to round up here in this video, expecting to meet in our next video. Okay students, goodbye.